Okay, today we're starting 6.6, day one. We're going to solve exponential equations. Exponential equations, remember, that's when the variable is in the exponent spot. Today we're going to try to rewrite them with the same base. So the property of equality for exponential equations, let b be a real number with b not equal to 1. So here's the fact. The fact is going to make common sense to you. So it says b to the x equals b to the y if and only if x equals y. So they're saying if this equals this and they have the same base, well, then they must have the same exponents. Okay, I'm going to tell you a fun abbreviation. If and only if means it's definitely true, and the abbreviation is IFF. Okay, so let's look at these. For the example, we're going to rewrite the equation with a common base if necessary, and then we're going to solve for x. So this is what the property is saying. So I have 5 to the x minus 3 is equal to 5 to the 4. Well, if they have the same bases and they are equal, they must have the same, their exponents must be equivalent. So this must equal to this. So I'm going to say, well, since they equal, their exponents equal. Okay, then I can solve this and find that x equals 7. Okay, if you plug it in, it makes sense. If I plug 7 in here, 7 minus 3 is 4, and 5 to the 4th equals 5 to the 4th, of course. So let's look at this one. For b, it says 3 to the 2x equals 3 to the x plus 7. They have the same base, and they're equal, so their exponents must also be equal. So it must be true that 2x is equal to x plus 7. And then we can use our algebra to solve. I'm going to minus the x over. So 2x minus x is 1x. So x equals 7, and again, if you plug it back in, you can verify that it makes sense. Okay, now let's look at ones that get a little trickier, but it's the same idea. Okay, so for C, it says 7 to the 3x plus 5 equals 49. I know if they have the same base, they have the same exponent, but right now they do not have the same base. The question is, can I rewrite them so they have the same base? I have 7 to the 3x plus 5. Can I rewrite 49 in terms of a base 7? Yes, I can make it 7 to the second power. Okay, so now let me bring this down. So if I have 7 to the 3x plus 5 is equal to 7 to the second, since they have the same base, their exponents must equal each other. So 3x plus 5 must equal to 2. And now I can solve. Okay, and whenever I put the yellow steps, you don't need to show them, but some people show them because they're helpful to them. Okay, let's look at D then. Okay, D is 2 to the x minus 1 equals 8. They do not have a common base right now. So I'm going to rewrite. I normally look at the bigger number to start with because I know for sure that's going to have to get rewritten. So 8 is, what is 8? 8 is 4 times 2, which is 2 times 2. So this is 2 to the third. Okay, well, if I make this 2 to the third, and this is 2 to the x minus 1, now they have the same base. So now I can do use the property that the exponents must equal each other. And then if I add the 1 over, I get x is 4. Okay, and you don't have to check them, but again, these should make sense. If I plug 4 back in the original, 4 minus 1 is 3, 2 to the third equals 8. It works. Okay, let's look at E. Oh, they are starting to get trickier. Okay, they do not have the same base right now. This has a base of 5, this has a base of 25. I'm going to look at the bigger number and at least see if I can rewrite the 25. Right, 25 is 5 times 5, so it's 5 to the second power. Okay, which is good, except what do I do with the x minus 1? Well, the x minus 1 is in the exponent spot, so we're going to keep it in the exponent spot, but I am going to put it in parentheses because I'm kind of doing 5 to the second to the x minus 1, so I'm going to multiply the exponents. Okay, it's complicated looking, but since they both have a base of 5 and they're equivalent, we can make their exponents equal to each other. Okay, let's go ahead and solve. I need to distribute. Was that 2x minus 2? Okay, move the x's to one side. Okay, and then if you're comfortable, go ahead and move the numbers at the same time. So 2x cancel equals negative 9. So x equals negative 9 halves. And we often get fractions, so don't worry. Okay, let's try f, another tricky one. Okay, do they have the same base? 6 and 36. No. Let's look at the bigger number and see if we can rewrite that. 6 times 6, so it's 6 to the second power. So I'm going to make this 6 to the second power. It already had an exponent of 4 minus x, so I'm doing 6 to the second to the 4 minus x, which means I'm going to multiply the exponents. Put parentheses to make sure you multiply the whole thing. Okay, since they now have the same base, I can make their exponents equivalent. And if you are comfortable distributing when you bring it down, I'm okay with that. 2 times 4 is 8 minus 2x. Okay, and then go ahead and use your algebra. I'm going to move the 2x over. Okay, I'm going to bring it down, but if you want to cancel the 5 at the same time, go ahead. As long as you are showing your steps along the way, your work could be different. Divide 5. Looks like I got a fraction again, so I have x equals negative 3/5. Okay, let's keep going. Each time we're going to get it a little trickier. Okay, let's look at G. 4 to the 2x minus 5 equals 8. Again, not the same base. Let's try to rewrite the 8 first as an exponent. So 8 is, what is 8? 4 times 2. So 2 times 2. So this is 2 to the third. Okay, but that still doesn't match. This is a 4, this is a 2. So now I need to think about the 4. Can I rewrite the 4 with the base of 2? Oh, sure, I can make it 2 squared. Okay, so let's make this 2 squared. Since the 4 had an exponent of 2x minus 5, I multiply the exponent. Okay, now they have a common base, so now I can go ahead and make their exponents equal to each other. Okay, and if you're comfortable distributing in your head, go ahead. I'm going to do it now. Okay, and then go ahead and solve it. Remember, fractions are our friends. Don't panic. Okay, I got x equals 13 over 4. I could plug it in to check, but I don't want to deal with that fraction, so I'm going to be confident in my answer. Okay, let's look at h. It's going to be a similar problem. 125, 25. They do not match. I'm going to go ahead and try to rewrite the bigger one. But sometimes if you see one, you can do whatever you want first. What do I times to get 120? It divides by 5. What's 125 divided by 5? 25? Okay. 25 is 5 times 5. So I can make this 5 to the third. Okay, but it already had an exponent of x plus 3. So let's multiply by x plus 3. Okay, does it match? No, it doesn't match. So let's rewrite 25. 25 is 5 times 5, so I can make that 5 to the second power. That one also had an exponent, so let's multiply by the exponent that was already there. Okay, now that they have the same base, we can set their exponents equal to each other. Okay, and if you distribute it and then bring it down, that's fine with me. 3x plus 9, 8 minus 2x. Okay, move your x's to one side, move your constants to the other, and you could do it at the same time. Let's move the 9 at the same time. Okay, 5x equals negative 1. So x equals negative 1/5. Okay, 2 more. All right, and yes, they're going to get a little trickier. This is the hard ones. Okay, I have 8 to the 4x, and I have 1 over 2 to the x minus 12. Both look equally terrible. Let's start with the bigger number. Let's rewrite 8. What is 8? 8 is 4 times 2, 2 times 2, so it's 2 to the third. And it had a 4x, so times 4x equals, okay, I want this to have a base of 2. It's 1/2. It's upside down. So how do we rewrite that? It's 2 to the negative 1, because the negative flips it. Okay, I'm going to keep the x minus 12 there. Okay, and now they have the same base. This is one way to write it. I could have also started with the 1/2 and rewritten the 8 with a negative exponent, and I would get the same answer. So if you can get them to have the same base, and it's a correct step, then your method will work, even if it looks different than my method. Okay, so let me go ahead and set these equal. Should I multiply as I go? 3 times 4x is 12x. If I distribute the negative 1x, negative 1 times negative 12, positive 12. Okay, I'm going to move the x's together. And then divide by 13. Okay, x equals 12 over 13. Okay, last one. Challenge. Okay, bases do not match. If they matched, I don't mind a fraction as long as they match. Which one should we start with? Let's go 81. Okay, 81 is 9 times 9. So I could do 9 to the second, but that doesn't match the 27. So let's go farther. Let's go to 3's. If the other base was a 9, I would have stopped, but it's not. So let's make this 3 to the 4th. And then keep the x minus 2 there. Equals. Now I need the 27 to be written in terms of a 3. It's going to be negative because it got flipped. And then to get 27, what do we do? 9 times 3, 3, 3. Some of you know that in your head. So 3 to the negative 30 is 1 over 27 because 3 to the third is 27 and the negative flips it. Okay, I'm going to bring over the negative 5x. Okay, once you get the same base, you've kind of done the hardest part. So let's make the exponents equal. I'm going to multiply as I go. Negative, negative, that's a positive 15x equals 4 times x, 4x minus 8. Okay, move the x's to the same side. Okay, x equals negative 8 over 11.